Hey everybody, welcome to the periodic table of elements. Just a quick little introduction onto ionic notation in case you missed it in class. So what we're going to do is before we get into the actual ionic notation side of things, we're just going to recap the periodic table of the elements first. Now, when you see the periodic table of elements, there are a whole bunch of pieces that we need to know about when we're doing ionic compounds. So first thing we want to know is on the left-hand side here, we have these numbers 1 to 7, these rows, 2, 3, 4, 5, 6, and 7. Now these rows represent the valence rings, which we're not going to focus on right now. What we do want to focus on are the columns going up and down. So 1, 2, and then we have a whole bunch here for these metals that we're going to ignore. And it picks up at 13, 14, 15, 16, 17, and 18. Now these are going to be important for us for our ionic notation where we're looking at charges. So what that's going to represent is, this is going to be how many electrons, when we draw our Lewis model, how many electrons are we drawing each time. So if it's in the first column, we draw 1, second column will be 2. If we get to this column here, 13, we can actually just ignore the 1 to help us out. So this will be 3, 4, 5, 6, 7, and 8. Now if we recall, so for example, let's use neon as an example. Our ionic notation, if we drew it out, we would have to find neon on our list, which when we look at it, it's actually in column 18, the noble gases, and it has 8 electrons that need to be placed. So if we were drawing a Lewis diagram, and I know I'm kind of doubling up, which I shouldn't be, I should be going clockwise, but we have 8 electrons that are being placed. So this is what we call stable or full. So if you remember from valences, it can only hold 8 on the outer shell, which is perfect for us for neon, which means it is full and we don't need to worry about that. However, if we get one such as lithium, which is in column number 1, it only has 1 electron. Now, when we start combining these, we're going to start getting into cations and anions, which is the loss and gaining of different electrons. Ionic means that these elements are going to be donating or gathering extra electrons to make them positive, to help make them stable. So when we're drawing an ionic compound, an ionic notation, all we do is we find out where it is on the periodic table. So for example, I'm going to pick aluminum. Okay, so aluminum is in column 3, which means it has 3 electrons. Now, it is easier for this aluminum to move backwards to its next closest full valence than trying to gain 5 to hit full 8. So what's going to happen is these electrons are actually going to be taken away, and it's going to end up 3 electrons less, or 3 negative charges less, which will give you a positive 3 charge. Okay? If we have an example such as, let's go chlorine, which is in column 7 or 17, it's going to have 7 electrons, which means in order for it to be full, it's easier for it to gain 1 electron than to get rid of 7 and move all the way back. So it's going to gain an extra electron, and because it has 1 extra electron, it will be 1 negative. And this is how we write ionic notation based on the elements that we find on the periodic table. So an example that you can do at home here before I shut off my video is oxygen. So I'll give you a moment to find it. If you need to, stop the video. Okay, so if we find it, we find out that oxygen is in column 16, which means it has 6 electrons that need to be placed. So 1, 2, 3, 4, 5, 6. Now, because it's easier for this to gain 2 rather than get rid of 6, it is going to gain 2 electrons, and because it's now 2 electrons heavier, it now has a negative charge of 2 as a result. Right? So these are just a quick example on how we can write ionic notation from the elements in the periodic table. Hope that helped. Have a good one. Take care.